Would you believe that thousands of years ago, humans moved enormous stone blocks and built structures that still amaze us today? They cut stone with astonishing precision, fitted walls together with almost no gaps, and constructed massive monuments without modern machinery. Some techniques have been explained, but many questions about how these structures were built are still debated today. Before we begin, tell us which ancient structure fascinates you the most, and which mystery you would most like to see explained. Today, join us as we explore the world's most mysterious ancient structures and discover how people thousands of years ago may have actually built them. More than 1,500 years ago, water flowed through underground channels at the foot of Sigiriya and rose from fountains in the royal garden. Sigiriya was built by King Kassapa I in the 5th century on a granite rock about 590 feet high in the middle of Sri Lanka. On the top of the rock are the remains of the palace, while the path upward once passed through a giant lion-shaped gate. But the most astonishing engineering lies below. The water gardens are arranged symmetrically, with ponds, canals, and fountains connected by an underground hydraulic network. Part of that system still works during the rainy season after about 15 centuries. Around the foot of the rock, moats, walls, rock gardens, and stairways were combined with the terrain to protect the site and guide people upward. Along the rock face, famous frescoes and the mirror wall still remain, showing that this place was carefully planned in both engineering and beauty. Sigiriya was ahead of its time, not only because the palace stood on a steep rock, but because water, landscape, defense, and architecture were organized into one single system. Nearly 9 centuries ago, the workers in Lalibela did not stack stones to build churches. They removed an entire part of the mountain, so the structure could appear inside one solid block of rock. The rock-hewn churches of Lalibela in Ethiopia include 11 medieval churches linked to King Lalibela and the idea of creating a new Jerusalem. The workers cut deep trenches around the natural rock, then kept carving the doors, windows, columns, floors, and roofs directly into that same rock, leaving almost no room for error. The two groups of churches are also connected by a network of trenches, ceremonial paths, and passages through the rock. Beit Medhani Alem is believed to be the largest monolithic church in the world, while Beit Orgis stands out with its cross-shaped plan, set apart from the other churches. Even rainwater was managed through an integrated drainage system around the complex. What makes Lalibela special is that it has never become only an archaeological ruin. It is still a center of pilgrimage and worship for Ethiopian Christianity. Lalibela was ahead of its time because its builders did the opposite of usual architecture. They did not raise a structure from the ground, but turned the mountain itself into walls, columns, roofs, and a space for worship. Every year, on the days around the winter solstice, a ray of sunrise passes through the small opening above the Newgrange doorway and travels almost 66 feet deep into the darkness inside. That moment has been calculated since around 3200 BC, when this structure was built in Ireland's Boyne Valley. Newgrange is a giant passage tomb made of stone and then covered beneath a large round mound of earth. Narrow passage leads to a central chamber with 3 stone recesses. Above it, stone slabs were gradually stacked inward to create a corbelled roof about 20 feet high, without concrete or a steel frame. But it is the roof box above the doorway that makes Newgrange special. At winter dawn, light passes through this opening and shines straight into the deepest room for a short time. The stones around the structure are also carved with spirals and geometric patterns, belonging to one of the most important collections of megalithic art in Western Europe. Newgrange is not astonishing because of its height. It is astonishing because, more than 5,000 years ago, its builders made stone, darkness, and the sun meet at the most special moment of the year. Nearly 2,000 years ago, the Romans brought water into Segovia with a huge structure that worked entirely because of the slope of the land. The aqueduct of Segovia is one of the best preserved Roman water systems, with its aqueduct bridge running through the center of the Spanish city today. The most unbelievable part is how it was built. About 20,400 granite blocks were stacked into pillars and arches with almost no binding mortar, and the weight of the stones themselves helped keep the whole structure stable. At Plaza del Azoguejo, the structure rises more than 92 feet, with 2 tiers of arches stacked on top of each other to carry the water channel across the lower part of the terrain. The whole bridge section has as many as 167 arches, but the water did not need any pump. The Romans controlled the slope of the route precisely enough for the water to keep flowing through the channel above, then be distributed to cisterns and fountains in the city. This system continued to bring water into Segovia until the 20th century. Nearly 2 millennia later, The granite arches still stand intact in the square, showing how the Romans turned gravity, geometry, and the weight of stone into a giant machine for carrying water. More than 1,000 years ago, the Khmer people turned a plain into an urban system where temples, reservoirs, and canals were linked together. Angkor in Cambodia was once the center of the Khmer Empire, with the archaeological area today covering about 154 square miles. Angkor Wat and Bayon are only the most visible parts. Beneath them lies a huge water control network. Water from Phnom Kulen flowed down to the Angkor Plain, then was guided through canals to reservoir, moats, and farming areas. West Baray is about 5 miles long and more than 1¼ miles wide. This system helped the Khmer store and redirect water while also supporting farming around the city. Even the moats around many temples had an engineering function, collecting rainwater and helping maintain the sand layer beneath the structures. What made Angkor ahead of its time was not only its massive stone temples, it was the way architecture, the city, and water were designed as parts of one system. Almost 900 years ago, the Sinagua people built a 5-story home inside a limestone alcove nearly 89 feet above a valley in Arizona. Montezuma Castle is not a castle, and it is not connected to the Aztec Emperor Montezuma. The structure had been abandoned almost a century before he was born. Inside are about 20 rooms, once used by many families like an ancient multi-story apartment building. The walls were made from local limestone, joined with mud mortar, and then covered with another layer of mud on the outside, while the floors and roofs used wood, branches, and earth. Under the waters off Yonaguni Island, giant stone steps, flat surfaces, and sharp angles look like the remains of a structure that sank into the ocean. Yonaguni monument was noticed by a local diver in 1986 and quickly sparked debate because its shape looked like man-made terraces. Some researchers, most notably Masaki Kimura, have suggested that humans may have built or modified this structure. But so far, there is not enough strong archaeological evidence to confirm that Yonaguni is the ruin of an ancient civilization, and Japan's cultural agency also does not recognize it as an archaeological site. Another explanation lies in the island's own type of rock. The sandstone layers at Yonaguni have natural bedding planes and cracks, allowing the rock to split into straight edges, steps, and flat surfaces that closely resemble architecture. On land at Saninudai, similar terraced landforms still exist, supporting the possibility that the sea and weathering created this special shape. About 4,600 years ago, the Egyptians built a structure nearly 482 feet tall without steel, engines, or modern cranes. The Great Pyramid of Giza was built as a tomb for Pharaoh Khufu and is the only wonder of the ancient world that still largely survives today. Each side of the base is about 755 feet long, and an estimated 2.3 million stone blocks were used, with a total weight reaching millions of tons. But size is only part of the achievement, as the four faces of the pyramid are aligned with extreme precision to the cardinal directions, showing the remarkable surveying skill of the ancient Egyptians. Inside is a system of passages, the Grand Gallery, and chambers set deep within the huge mass of stone. The king's chamber was built with granite blocks brought from southern Egypt, some of which weighed dozens of tons. The exact way the Egyptians transported, lifted, and organized the placement of millions of stone blocks is still being studied. The Great Pyramid was ahead of its time because it combined scale, geometry, and labor organization at a level rarely seen in the ancient world. More than 1,000 years ago, the Javanese turned a natural hill into a giant stone structure with many levels that gradually lead up toward the sky. Borobudur was built around the 8th and 9th centuries in central Java, Indonesia, and is one of the largest Buddhist monuments in the world. The structure has 5 square levels below, 3 circular levels above, and a large central stupa. On the 3 circular levels, there are 72 perforated stupas, each holding a Buddha statue, but the remarkable part lies in the way the structure handles water. Borobudur stands in a tropical climate with heavy rainfall, so the stone steps were combined with a drainage system and a series of stone spouts to carry water away from the structure. The walls are also covered with more than 26,900 square feet of reliefs, turning the path around and upward into a storytelling journey in stone. The andesite blocks were fitted together without relying on mortar, using joints and locking points to keep the structure stable. Borobudur was ahead of its time because architecture, drainage, and religious symbolism were combined into a single system, and the whole hill became a stone path leading pilgrims from the ground up to the stupa at the top. With no metal and no lifting machines, people of the Neolithic period still raised stone blocks weighing tens of tons into a precise circle on the plains of England. Stonehenge began to take shape about 5,000 years ago, and the giant sarsen stones at the center were erected around 2500 BC. On average, each sarsen block weighed about 25 tons, but lifting them was only part of the challenge. The builders also placed horizontal stone beams on top and locked them in place with carefully shaped joints, a special technique rarely seen in stone circles from the same period. The smaller bluestones were even brought from Western Wales, as far as about 150 miles from Stonehenge. The whole structure was also aligned with the movement of the sun. At midsummer, the sun rises close to the main axis of the stone circle, and at midwinter, the sun sets in the opposite direction. Stonehenge is astonishing because the people who built it did not only know how to move giant stones, they also combined stone joining techniques, geometry, and the movement of the sun into a structure that people still study after more than 4 millennia. In a narrow valley in Afghanistan, a brick tower about 213 feet tall still stands after more than 8 centuries, even though almost no city remains around it. The Minaret of Jam was built in the late 12th century under the Ghurid dynasty, an empire that once controlled much of the Afghanistan region and extended its influence to the Indian subcontinent. The entire body of the tower was built mainly with fired brick, but its surface was turned into a huge layer of decoration made of geometric patterns and Kufic script. The interior architecture is even more astonishing. The tower is made up of several cylindrical shafts that become smaller as they rise, set on an octagonal base and containing a double spiral staircase system inside. The builders had to control the weight of thousands of bricks with enough precision for the structure to be tall and slender while still remaining stable in a valley often hit by floods and erosion. The bands of writing running around the tower also include passages from the Quran, created directly with brick and decorative terracotta. The architecture of Jam later had a significant influence on the development of Islamic minarets in the region and farther toward the Indian subcontinent. The Minaret of Jam was ahead of its time because the Ghurids turned a simple material like fired brick into a tall, light, and finely crafted structure able to survive for more than 800 years. Nearly 3,000 years ago, the Urartu people turned a rock ridge about 330 feet high into the foundation for an entire capital city. Van Fortress, or Tushpa, stands beside Lake Van in eastern Turkey and was once the capital of the Urartu kingdom from around the 9th century BC. The fortress stretches along a natural rock mass more than 0.8 miles long. But the Urartu people did not just build on top of it. They cut and leveled the bedrock itself to create steps, foundations, and floor surfaces for the structures above, then placed large stone blocks into positions that had been prepared with precision. In the new palace area, archaeological traces show a structure that may once have been up to 3 stories high, with storage rooms and service areas set on a base carved directly into the rock. A drainage system was also built into the palace area. The most astonishing part lies inside the cliff face, where the Urartu kings had multi-room tombs carved directly into the rock, with some chambers reaching about 30 feet high and up to about 2,150 square feet in area. Cuneiform inscriptions were also carved right onto the rock face to record the kings and their campaigns. Van Fortress was ahead of its time because the Urartu people did not simply place a fortress on a rocky mountain. They turned the rock itself into foundations, rooms, tombs, and part of the entire architecture of the capital. A stone block weighing more than 120 tons sits in the wall of Sacsayhuaman. But what is even harder to believe is that it was shaped to fit the irregular stones around it. Sacsayhuaman was built on the high ground north of Cusco, beginning under the Inca Pachacutec and continuing through several later rulers. The Inca created 3 huge tiers of walls running in a zigzag pattern, turning the hillside into an architectural system that was both defensive and ceremonial. Some stone blocks reach about 28 feet high and were transported, lifted, and then adjusted face by face so their edges touched almost perfectly. There were no modern cranes, no electric stone cutting machines. Yet the workers still turned stones of different shapes into a wall locked tightly together by their own geometry and weight. Sacsayhuaman was also not simply a fortress. Peruvian sources describe it as once having temples, towers, storehouses, pathways, and water channels, and as being seen as the House of the Sun in Hanan, Cusco. What makes Sacsayhuaman ahead of its time lies in the way the Inca turned giant stones into a structural system so precise that the entire mountainside became part of the construction. Three stone blocks each nearly 66 feet long and weighing about 900 tons, still lie in the ancient foundation of Baalbek. Baalbek in Lebanon was once a major religious center, later called Heliopolis by the Romans. They built the Sanctuary of Jupiter, one of the largest temple complexes in the Roman world, and the most famous part is the Trilithon. 3 giant limestone blocks were placed in a row in the foundation wall of the temple complex, but Baalbek also contains even larger stones. In the nearby quarry, one block that was never moved is estimated to weigh about 1,800 tons. How ancient people transported and placed these enormous stones is still being studied. Above the stone foundation once stood the enormous Temple of Jupiter, but today only 6 large columns remain standing. Baalbek was ahead of its time because ancient people turned stones weighing hundreds of tons into the foundation for a huge architectural complex. In the dry heat of Rajasthan, ancient people built a structure that led people deep underground just to store and reach water. Chand Baori is in the village of Abhaneri, India, and was built around the 9th century under King Chanda. What feels most overwhelming is the roughly 3,500 narrow stone steps, arranged symmetrically into repeating geometric patterns on 3 sides of the well. The steps allowed people to keep going down, to collect water as the water level dropped during the dry season. When the water rose again, they only needed to stop at the higher levels. But Chand Baori is not just a giant well. The deep underground space also created a place to escape Rajasthan's harsh heat, and once became a gathering place for the community. On the steep mountainside above the sacred valley, the Inca turned land that was almost impossible to farm into giant terraces. Pisac is in the Cusco region of Peru, where farming, architecture, and defense were arranged directly according to the Andes landscape. Stone walls helped hold the soil, control water, and reduced erosion on the steep mountain slopes. But Pisac's engineering went even further, with water channels carrying water through areas at different elevations without pumps. The Inca even created a narrow passage through the natural rock on the mountainside. High above is Intihuatana, a ceremonial area with precisely worked stones connected to observing the sun. On the opposite side, there is also a large Inca cemetery with thousands of burial niches carved into the mountainside. Pisac was ahead of its time because the Inca did not try to change the mountain. They turned the terrain itself into part of the system. Imagine a huge structure that could hold tens of thousands of people, yet was built entirely on flat ground, with no mountain, no hillside, only the intelligence of the ancient Romans. The theater of Marcellus in Rome solved this problem with a system of arches, radiating walls, and load-bearing corridors beneath the seating area. Instead of cutting seats into a mountainside, as many Greek theaters did, the Romans raised the entire seating area above the ground with stone, brick, and concrete. The structure is about 427 feet in diameter and once held about 15,000 spectators. The inner corridors helped move the crowd to many different seating sections, while the outer tiers of arches both carried the weight and reduced the amount of material needed. The theater of Marcellus was ahead of its time because the Romans turned a theater into an architectural system that could support and manage a huge crowd right in the middle of the city. In the rainforests of Central America, the Maya built giant stone pyramids many centuries before modern building techniques appeared. Maya architecture created large cities such as Tikal, Palenque, Uxmal, and Chichen Itza. The amazing point lies in how they dealt with the limits of their environment. Many temples and palaces used corbel arches, where each layer of stone gradually projected inward until the opening above was closed. At Tikal, the central urban area, covering about 988 acres, was connected to artificial water reservoir. The Maya also brought their knowledge of the sky into the layout of their buildings, and at Uxmal, UNESCO confirms that the architectural plan shows astronomical knowledge, while Chichen Itza has El Caracol, a round tower, linked to observing the sky. More than 4,000 years ago, the Sumerians raised a temple high on a huge architectural mass in the middle of the Mesopotamian plain. The ziggurat of Ur was built by King Ur-Nammu around 2100 BC in the city of Ur in what is now southern Iraq. The core of the structure was made from millions of mud bricks, a cheap and readily available material, but one that rain could easily destroy. The solution was in the outer shell. Workers covered the core with more durable fired bricks and bonded them with natural bitumen to improve resistance to water and erosion. The walls were also built slightly leaning inward to resist the pressure from the enormous mass of bricks behind them. Three large stairways led up to the higher levels, where there was once a sacred area dedicated to the moon god Nana. The ziggurat of Ur was ahead of its time because the Sumerians understood that to build very large with weak materials, they had to control weight, pressure, and water within the design itself. The giant stone blocks at Alatri were cut into many shapes and fitted tightly together with almost no mortar. Alatri sits on a hill in Lazio, Italy, where the ancient Acropolis is still surrounded by massive polygonal walls. The large limestone blocks were shaped edge by edge, so they locked together through their form and weight. Some wall sections are more than 50 feet high, while the outer circuit once stretched nearly 1¼ miles around the ancient town. But the most impressive part is Porta Maggiore. The entrance to the Acropolis is covered by a single stone beam more than 16 feet long, laid across the top of the gate without modern steel or concrete. Inside the retaining wall sections, rubble helped increase stability and support drainage. Seen from above, Moray looks like a giant arena carved into the ground, but these circles may once have served a much more practical purpose. Located near Maras, in the Cusco region of Peru, Moray is made up of rows of concentric circular terraces that descend into deep depressions. What is special is that the different levels create different microclimates within the same area. For this reason, the Cusco Cultural Authority identifies Moray as having once been an agricultural testing center, where the Inca used different ecological levels to expand farming possibilities. In other words, they could observe how crops reacted when environmental conditions changed without needing to move to another valley. The astonishing thing lies in how the Inca turned the terrain itself into a research tool. No modern greenhouses, no sensors. With only stone, soil, elevation, and the layout of the terraces, they created many farming environments within a relatively small area. On a steep ridge in the Andes, the Inca built an entire city at an elevation of more than 7,900 feet without letting heavy rains wash it down into the valley. Machu Picchu was built in the 15th century and is often seen as a royal residence linked to Inca Pachacutec. But the most ahead of its time part lies beneath the terraces. The terraces both created farmland, held the mountainside in place, and reduced erosion. Under them are many layers of stone, gravel, and soil that help rainwater drain downward instead of building up and causing landslides. The Inca also guided water from a natural source through stone channels to the residential area, while carrying excess water away from the structures. The stone walls were fitted tightly together and laid out directly according to the terrain, making the architecture almost blend into the mountainside. Machu Picchu was ahead of its time because the Inca did not just build on a mountain. They turned the slope, stone, and water into the very system that kept the city standing for centuries. A stone block weighing about 500 tons seems to be floating on the water, but it was actually carved directly from the mountainside behind it. Ishi no Hoden is located at Oshiko Shrine in Takasago, Hyogo Prefecture, Japan, and is often believed to have been created around the 7th century. The stone block is about 25 feet long, about 21 feet wide, and more than 18 feet high. Ancient workers dug deep around 3 sides, separating almost the entire structure from the natural bedrock, then smoothed many of its surfaces with chisel-like tools. But the most puzzling part lies underneath, where a small section of stone, still connected to the bedrock, is hidden by water, making the giant block look as if it is floating on a pond and giving rise to the name floating stone. To this day, it is still not known for certain who made it, what its original purpose was, or whether the structure was ever meant to be moved from this place. Modern 3-dimensional laser measurements have even been used to study the shape of the stone block, but the question of its function still has no certain answer. Ishi no Hoden is astonishing not because of legend, but because ancient people removed a huge amount of stone to create a 500-ton structure almost separated from the entire mountain. More than 8 centuries ago, Norwegian builders raised a church made almost entirely of wood, but they did not set the load-bearing posts directly into the ground. Borgen Stave Church was built around 1180 in Lærdal and still stands in its original location today. The secret lies in the frame underneath. The load-bearing wooden posts, called staves, were placed on a system of horizontal beams and lifted off the ground by foundation stones, helping the main frame avoid direct contact with damp soil. The wall planks were slid into grooves in the lower and upper beams, while many structural pieces were secured with wooden pegs. The main material was old heartwood pine, with tight growth rings and a high resin content. Above, 7 roof levels, wooden shingles, and carved dragon heads create Borgund's distinctive shape. The entrances are also covered with intricate carved patterns. Borgund impresses not with enormous size, but with the way medieval craftsmen understood wood deeply enough to turn posts, grooves, and pegs into a frame that has survived for more than 800 years. To enter this place, you first have to cross an area of sharp limestone covering the ground before reaching the dry stone wall rings. Behind them is Dún Angasa, an ancient fort on Innismore Island off the west coast of Ireland. The structure began to take shape more than 3,000 years ago and was expanded through many stages. 3 rings of walls enclose the inner area, but the side facing the sea almost needs no extra wall. There, the cliff drops straight down to the Atlantic Ocean and has become the fort's natural boundary. The most unusual part lies on the landward side, where thousands of sharp stone slabs are set closely together in a layer of chevaux de frise, making a direct rush toward the gate almost impossible. Inside, archaeology has also found traces of homes, metalworking, and daily life that continued through many periods. Dún Angasa does not impress with height or huge size. It impresses because 3,000 years ago, its builders understood exactly where a wall was needed and where the deep cliff could do the rest. Imagine an ancient city built not just for living, but to turn the land itself into a defensive weapon. That is Hattusa. More than 3,000 years ago, the Hittites built this capital on the rocky hills of Anatolia, in what is now Turkey. Instead of leveling the land, they ran their walls along the mountainsides and turned the natural slopes into the first layer of defense. Great gates such as the Lion Gate were placed at key access points, forcing anyone entering to pass through tightly controlled routes. But the most special part was still beneath the walls. A stone tunnel, called a potern, passed through the base of the fortifications and created a secret passage between the 2 sides of the defense system. Hattusa was ahead of its time because its builders did not see the Rocky Mountains as an obstacle. They turned height, slopes, city walls, and tunnels into parts of one single defense system. An architectural mass more than 650 feet wide rose in the Valley of Mexico nearly 2,000 years ago, so large that it still dominates the entire skyline of Teotihuacan today. The Pyramid of the Sun has a base about 738 feet wide on each side and once reached a volume of nearly 35 million cubic feet, making it one of the largest structures in ancient Mesoamerica. What is remarkable is that the main part of the pyramid was built during one major construction phase around the 1st century to the early 2nd century, but it did not stand alone. The Pyramid of the Sun was placed within a city planned along a geometric axis, connected with the Avenue of the Dead and many temples and ceremonial plazas. Beneath the pyramid, there is also a tunnel leading to a branching underground space, showing that this location may have held ritual meaning even before the giant structure above was completed. The Pyramid of the Sun was ahead of its time because the Teotihuacan people combined scale, geometry, and urban planning to turn millions of blocks of material into the center of an entire ancient city. At an elevation of nearly 12,630 feet on the Bolivian plateau, the Tiwanaku people built Puma Punku with stone blocks worked with astonishing precision. Puma Punku is part of the Tiwanaku Ceremonial Center, which flourished from the 5th century to the 10th century. The base of the structure used large sandstone slabs, while above it there once were andesite blocks cut into doorways, niches, and complex geometric shapes. Some blocks have flat surfaces, sharp edges, and interior right angles that were finished before being set in place. Most notable are the H-shaped blocks, many of them almost repeating the same form, showing that the craftsman worked with a system of proportions and modules. Some joints also have grooves for metal clamps, helping link the architectural parts without depending entirely on mortar. Today, Puma Punku is only scattered stone blocks, but those very fragments show that the Tiwanaku people combined geometry, stonework, and assembly in an astonishingly standardized system. In the middle of a lagoon in the Pacific Ocean, ancient people built an entire ceremonial center on more than 100 small artificial islands made of coral and basalt. Nan Madol lies off the coast of Pohnpei, Micronesia, and became the center of power of the Sodelur dynasty from about the 12th century to the 15th century. The islands are separated by narrow water channels, forming a network that connects palaces, temples, tombs, and living areas. But the most unbelievable part is the material. Long basalt columns were stacked in crisscrossing layers like giant logs, creating stone walls right on a coral foundation in the water. and some basalt blocks may weigh up to about 50 tons. The stone was also brought from many different sources on Pompeii, making its quarrying and transport a huge logistics challenge for a society without modern machinery. The exact method used to move the heaviest blocks has still not been determined with certainty. Nan Madol was ahead of its time because the Sodalur people turned stone, coral, and water into the foundation for a huge architectural complex in the middle of the ocean. More than 4,000 years ago, the people of Mohenjo-Daro lived in a city with planned streets, wells, and a drainage system built from the very beginning. The city took shape around 2500 BC in the Sindh region of present-day Pakistan and was once a major center of the Indus Valley civilization. Relatively straight streets divided the residential areas into clear blocks, while fired bricks were made in standard sizes for use on a large scale. But the part most ahead of its time lay beneath the streets. Water from many homes was led into brick-built drains and sewers, while many neighborhoods also had wells close to the houses. In the higher area was the Great Bath, a large public water tank that was carefully waterproofed and may once have served bathing rituals. What is notable is that archaeology still has not identified massive royal palaces or tombs like those of many civilizations from the same period. Artifacts such as the bronze dancing girl and the stone figure often called the priest king show a refined society, but its system of power remains mysterious. Around 1900 BC, the city was gradually abandoned as the Indus civilization declined. Today, the remaining brick walls still show the most amazing thing about Mohenjo-Daro, a city designed as one unified system. More than 2,000 years ago, anyone entering Maiden Castle had to pass through layers of ditches and earth ramparts that curved like a giant maze on the hillside. Maiden Castle in Dorset, England, is one of the largest and most complex Iron Age hill forts in Europe, with a defensive system that began to expand greatly about 2,400 years ago. At its greatest stage of development, the inner area covered about 49 acres and once had more than 100 round houses. But the most astonishing part lies on the outer ring, where the builders created up to 3 layers of earth ramparts and many deep ditches, forcing anyone approaching to keep changing direction before reaching the gate. At the entrances, narrow winding paths forced attackers into open spaces between the ramparts, where they could easily be watched and attacked from above. The whole rampart system was made mainly from earth and chalk, dug right from the hill, but its scale required hundreds of people working over many generations. Under an ordinary town in Cappadocia lies an entire city carved nearly 280 feet deep into volcanic rock. Derinkuyu in central Turkey grew into a multi-level shelter, once used by Christian communities to hide from attacks. But these were not just rooms dug underground. The levels were connected by narrow corridors, with animal stalls, food stores, living areas, chapels, and wells deep inside. Air was brought down through ventilation shafts that ran through many levels, allowing people to keep living when the entrances above were closed. And when danger appeared, huge round stone doors could be rolled sideways to block the tunnels from the inside. The corridors were deliberately narrow, making it hard for invaders to move in large numbers. Today, 8 levels of Derinkuyu are known to be accessible, revealing only part of the network beneath Cappadocia. On an isolated island in the middle of the Pacific Ocean, the Rapa Nui, people carved hundreds of giant statues and then moved many of them away from the quarry to stand on ceremonial platforms around the island. Today, more than 900 moai have been recorded on Rapa Nui, and Rano Raraku alone still has about 400 statues in different stages of carving. Most of the process began right on the slope of the volcano, where workers dug channels around the stone block and slowly separated the whole body of the statue from the bedrock behind it. But finishing the carving was only half the challenge. The statues had to be moved across volcanic rock terrain to the AHU, the ceremonial stone platforms, scattered around the island. Some statues were also given pukao, made of red volcanic stone, on their heads, creating another challenge of moving and lifting heavy objects. One archaeologically tested theory says that moai may have been kept upright and pulled alternately with ropes so they could move forward step by step, and experiments show that a group of only about 15 to 50 people could carry out this process. In the middle of Yemen's desert, an entire city rose straight toward the sky using the simplest materials imaginable: sun-dried earth and straw. Shibam lies in Wadi Hadramaut and is considered by UNESCO one of the oldest and most complete examples of urban planning based on the principle of building upward. Most of the city's current appearance took shape in the 16th century, after a major flood destroyed many older structures. Inside the city walls, tower-like houses were built close together on a compact network of streets and small squares. Many buildings rise to about 7 or 8 stories, equal to nearly 100 feet, even though most of the structure uses only sun-dried mud brick. The lower walls are made thicker, then gradually narrow as they go higher to reduce weight and keep the building stable. The lower floors usually have very few windows, both to increase defense and to create space for storing food or keeping livestock. Building high also allowed many families to live in a small area inside the city walls, instead of expanding into the plain where floods were a threat. And the building material was almost right beneath their feet. Soil from the agricultural system around the wadi was used to make new bricks and to regularly repair the wall layers eroded by rain. Shibam solved the problem of space by building an entire city vertically upward from the desert earth. A stone block weighing more than 16,000 tons still lies on the slope of Yangshan because the people who made it ultimately found no way to move it away. In 1405, the Yongle Emperor ordered stone to be quarried at Yangshan, near Nanjing, to build a giant stele in memory of his father, the Hongwu Emperor, at the Ming Shaoling Mausoleum. The workers began cutting the 3 parts of the stele directly from the mountain: the base, the body, and the headpiece. The stone base alone weighed about 16,250 tons, while the stele body was about 167 feet long and weighed nearly 8,800 tons. If the 3 parts had been fully erected, the structure could have stood about 256 feet tall and weighed more than 31,000 tons. But that very scale broke the plan. There was no practical Ming Dynasty transport system to move these enormous stone blocks from the mountainside to the mausoleum, so the project was eventually abandoned.